I'll be trying to share my screen now, and let me know if you are able to see whatever I'm trying to show. Just a second. Share. Okay. Are you able to see I'm like my screen, my entire screen? Okay. Up until our last lecture, we have seen, or we have actually learned a bit of control flow. So we were dealing with control flow there. And from there, we got to know that control flow is basically what? This is basically, okay, so control flow is basically if we have certain portion, if in like in terms of, if we see a if condition, so let's say we have this if condition in the source code. So if, let's say, A greater than B, then perform these statements. Else do some other statements. So this is statement, this is statement 1 and statement 2. Hence, if we convert this into a flowchart, then we would see the code starts from here. It enters the condition, or better show it in condition format. So that's the condition. Then in case of yes or true, we perform something. In case of false, we perform something else. Am I audible? Like, can you hear me? Hello? Okay, okay. I was testing if something went wrong or not. So yeah. So basically, in case if A is greater than B, then perform statements 1, and if A is less than B, then in that case, or less than equals to B, then in that case, perform statements 2. That's basically representing we're having a control here. So the control is basically the layer or the flow of the source code. And in case it encounters a condition, it simply performs a or goes to a true statement or a false statement based on the its output of this result of the condition. It performs some statements or performs some actions which are in different region. Now their control or their flow differentiates, or simply, in other words, their flow now changes. So now if we try to see, just a second, let me. Yeah, so in the last lecture, we have seen the control flow could be of, in basic terms, or the most crucial ones are of, let's say, two types. So, sorry, three types. The first one being the if condition, but in this case, it's only if then we have the Boolean expression, then we have the statement. So this is one such. In the next one, we have if Boolean expression as statement one. However, we also have now the else part. So we have a else and statement two. And finally, we do have a while or the looping condition. Now, you could ask where does the or where did I place or why didn't I place basically the for loop? Yeah, for loop also is a conditional part. So we can have the for loop here as well. In that scenario, what happens? That basically happens that for will have a Boolean expression inside. Also, beside Boolean expression, there are some operation going on. What are those operations? The first one being we have an expression. The expression is simply we could represent it as E. Why expression we have? Because we simply increment. For example, if we have like in case of for the C language, how do we write things? So we have int let's say I equals to 0. Then we have the condition. So I, let's say less than B. And then we have I plus incrementation. So that means we have a declaration portion. We have a condition, the Boolean expression, which is this one. And we have a normal expression here. So if we try to write it in terms of non-terminals or the grammars we provided, there will be a declaration portion. Then there will be this Boolean expression. And finally, there will be normal expression here. And we will have a statement here. So this will be something the production rule for the for loop condition will look like. Okay. So these are the control flows or structure of the grammar of the control flows. Basically, we will be covering so far. Now, let's do some examples here. In the last lecture, I introduced or I tried to write the grammar or the simply the production rules and like as well as the symmetric rules. However, I didn't get enough time to actually complete the tasks. So let's try to do it in this class. Let me at first erase this. So let's say we have this production rules present. Oh my God, the ink is so bad here. The productions, which are basically, let's say, the first one being pre-producing S, and we will have the corresponding semantic rules. So in case we see pre-producing S, we'll have S dot next equals to a new label, and P dot code will be basically whatever will be the S dot code, we will append with it a label code S dot next. Okay, this is the first one. Then we will have S producing assign. Now, why is producing assign? If you have encountered or if you have been present in the like some of the previous lectures, we did see we had something of this format. S producing what? S producing E or basically, sorry, not E, we had rather S producing ID equals E, or E equals L, isn't it? We had something of this format where E could be some ID before ID. It could be E1 plus E2, or it could be ID, or it could be an L, where L is basically what? An array. L is basically ID number or L number. So multi-dimensional array or a single dimensional array. Now, if we look here properly, in case of this scenario, the left E will be basically ID because E produces what? E can produce ID here. See, E produces ID. So this is a possibility. At the same time, here L is an array. So that means the grammar will simply, if we consider that simplified production rule, so S will produce what? E producing L, and this E can generate ID, and this L can, for example, generate some L number if in case of multi-dimensional array, and this L will generate ID number. That means the final thing will be what? ID equals to ID number and what? Number. So this will be the scenario. That means we will have a multi-dimensional or a two-dimensional array with some ID or with some name attributed to it, and that value from that array, the value we receive from this array will be placed to some different ID here. Okay. Now, let's get back to where we were before. So S has this now assigned because we were assigning something. Now, why assign? We will be getting to that a bit later, but this assign will have a semantic rule of S dot code will be equals to assign dot code. So whatever the assign or whatever the statements will have as code, that will be passed to S dot code. Now comes the conditional part. So if S produces if parenthesized B, which is Boolean expression, and S1, then the semantic will be basically B dot true will be a new label. B dot false will be equals to S1 dot next, which is basically the same as S dot next. Now we'll be coming to that a bit later, but so far bear with me, or so far try to stick with me. Then finally we will have S dot code equals to, now look at one thing. This S dot code is basically the three address code we will be generating, and the true or B dot true, these are all labels. These are not these are not the three address code we are trying to write. Rather, these are what? These are the labels which we are trying to impose. Okay, now S dot code will be basically whatever the B dot code is, we will append the level with it, level of B dot true. Then with that, we will append S1 dot code. With that, we will append or basically generate go to code. So go to S dot next. And finally, we will append to that the last level, which is B dot false. And along with that, we will append the S2 dot code. Sorry, this is, I'm writing the production rule for the symmetric rule for the if else part. Pardon for that. I need to erase some of this symmetric rule. So basically here I have to write up until S1 dot code. So no generation of go to statement. Sorry for that. So this is basically the symmetric rule I will be writing for only for if else, only for the if condition. Now for the if else part, we require this portion, which is S producing if production if then parenthesis B, which is the Boolean expression, then S1 else S2. In that scenario, we will have B dot true as a new label. Along with that, we will have B dot false. That's also a new label now. Then we have S1 dot next, which is basically S2 dot next, which is basically S dot next. Finally, we have S dot code finally we have S dot code equals to, we have B dot code. With that, we print the level B dot true. With that, we append the S1 dot code. With that, we append the like 3 address code, not level, rather 3 address code for a jump statement, which is to go to S dot next. Then we have level B dot false. And finally, with that, we append S2 dot code, since we have a second statement as well. These are the semantic rule for if else condition. After that, we will have just a second, let me fill this part. We will have S producing while parenthesize B and S1. For this or such region, we will have a temporary variable, as I mentioned earlier in the last lecture. So we will have a temporary variable begin, and to that we will impose a new label. So now no longer B dot true or B dot false will have at first the new label, rather the begin will have. Like in a bit, we will be like understanding why a new like begin rather than B dot true is a new or B dot false is a new label. Why we have this begin as the new label. Also, we do have a B dot true as new label, but the question is, why do I need to write this temporary variable as the new label? Why can't I write B dot true or B dot false or something B dot as the new label? Then we have we have B dot false as well.